Welcome to Get Your FRQ On. This is from the 2003 exam. It's question number 4, and it is not calculator active. In the question stem, we are given a function f, which is defined on the closed interval from -3 to 4. We are given that f of 0 is equal to 3, and we are given the graph of the derivative of f, which consists of a line segment and a semicircle. In part A, we are asked on what intervals the function f is increasing and to provide justification. Well, the function f will be increasing on any interval within that closed domain, -3 to 4, where the derivative of f is greater than 0. And since we are provided with the graph of the derivative of f, we need to justify our explanation using the given information. So our justification will rely on the graph of f prime, since we don't really know much else about this function f. So based on the graph of the derivative of f, f will be increasing on the interval from -3 to -2 because the derivative of f is positive on that interval. And given the graph of f prime provided in the question stem, this is the only interval on which f will be increasing. In part B, we are asked to find the x-coordinates of any inflection points on the open interval from -3 to 4 and to provide justification. And again, we don't know much about f, but we do have a graph of the derivative of f, so most of our justification here, if not all of it, will be based on the graph of f prime. So the function f will have an inflection point anywhere where the second derivative of f is equal to 0 and also changes sign. But again, we don't really know what f is, so we can't find its second derivative. The only thing we have is a graph of f prime. So if we can somehow turn the graph of f prime into information about the second derivative of f, we may be able to solve the problem and provide justification. Right, so the only thing we know about f prime is what we can infer from our knowledge of the only thing we know about f double prime is what we can infer from our knowledge of f prime, whose graph is given. Right, so the points where f double prime is equal to 0 and changes sign correspond to points on the graph of the derivative of f, where the derivative of f changes between increasing and decreasing. Right, based on the graph of f prime, f of x will have an inflection point at x equals 0 because the derivative changes from decreasing to increasing at x equals 0, and another inflection point at x equals 2 because the derivative changes between increasing and decreasing at x equals 2. In part C, we are asked to find the equation of the tangent line to f at 0, 3. In order to find the equation for the tangent line, we need to know the slope of the tangent line at f equals 0, 3. That we can get from the graph of the derivative of f. F prime of 0 is -2. So the equation of the tangent line to f as the point 0, 3 is y minus 3 equals -2x, or if you like slope-intercept form, y equals -2x plus 3. You could also write this in point-slope form, y minus 3 equals -2 times the group x minus 0. It's not necessary because x is 0, but if you had that, that would be acceptable as well. In part D of this question, we are asked to find f of -3 and f of 4 and to show our work. Now, in order to do this, we're going to need the fundamental theorem of calculus. All right, we're given in the question stem that f of 0 is 3, and then we can find both f of -3 and f of 4 by using the fundamental theorem of calculus. All right, for example, f of -3 is going to be f of 0 plus the integral from 0 to -3 of f prime of x dx. Using properties of integrals and the fact that f of 0 is 3, this is going to be 3 minus the integral from -3 to 0 of f prime of x dx, which is 3 minus negative 1.5, which turns out to be positive 4.5. So f of negative 3 is 4.5. Likewise, f of 4 would be f of 0 plus the integral from 0 to 4 of f prime of x dx. Don't have to switch the integral here because 4 is bigger than 0, but we do know f of 0 is 3, and we can calculate the area of the region between the graph of f prime and the x-axis using the formula for the area of a circle, and then take half of that because it's a semicircle. And we get 3 plus negative 8 plus 2 pi, which is going to be negative 5 plus 2 pi, and that would be f of 4.